Okay, what we're doing here is we're going to evaluate this expression without using a calculator. And this is cosine of tangent inverse 3/4. Now, tangent inverse can be thought of as an angle. So we could write tangent inverse of 3/4 is equal to theta. This means that tangent of theta equals 3/4. Theta is going to be between negative pi over 2 to pi over 2. I don't think we actually have to think about that. So what we're trying to do is we're actually trying to find cosine theta when tangent theta equals 3/4. One approach is by using identities. We could use tangent squared theta plus 1 equals secant squared theta, find secant squared theta, and then take the reciprocal. I am not going to do it that way. Maybe I'll do it both ways. I'm going to do it this way at first, though. Tangent theta equals 3/4, and tangent is opposite over adjacent. I am going to bring up graph paper. Okay. So I have that, and I'm going to make a triangle, a right triangle. Here's 3 is the opposite, and 4. It's the problem with graph paper. It looks nicer, but you have to think a little more sometimes when you're drawing these pictures. So here you have 3 and 4 if this is theta. Now, what is cosine theta? Cosine theta is adjacent cosine theta is equal to adjacent over hypotenuse. So I'm sort of the way there. I have 4 for the adjacent, but what's the hypotenuse? The hypotenuse I can find by using the Pythagorean theorem, although that is a Pythagorean triple. So pretty often we just know that it equals 3, 4, 5, So anyway, that is my answer. So I have the cosine of tan inverse 3/4 is equal to 4/5. I feel like maybe I can just drag this whole video on by showing how to use identities. But definitely will make a longer video, but we could do that. We could use identities. But actually, I don't think I'm going to do that. I already did this problem, so why not just quit while I'm ahead? But anyway, you could use tangent squared theta plus 1 equals secant squared theta, find secant squared theta, and therefore get cosine theta. Okay, so that is all.